Hello and welcome to a bonus discussion. I'll be talking about JSON. It's something that isn't really explicitly called out in the course, but it is quite relevant and quite useful. So I thought I'd go ahead and talk about it for a little bit, and then we could go through kind of some examples. First of all, well, what is it? The best way to learn is, if you're unfamiliar with it, is go take a look at the JSON website. So json.org, good place to start, and you'll land here. So basically, it came from the JavaScript world. Long ago, long ago, 99. Um, it came around as an alternative essentially to XML. That was kind of the motivation, because it is a lighter weight version of doing things, and it makes it easier to do things inside of languages like JavaScript. But it's also been used in pretty much every programming language at this point, I would guess, and it's a good thing for data exchange and so on. So it's basically got two kind of constructs, basic constructs. One of them is a name value pair. So this is essentially like a record, a structure, a dictionary, hash table, pick your list, associative array. It's a name value pair that goes together, and typically in this case it's going to be something like some sort of a variable name or identifier or a feature, and then there's some value that goes with it. Pretty much all programming language have this construct. And it makes total sense, because whenever you're exchanging data between places, it's necessary. So the basic idea, though, couple that with essentially an unordered list, and then things like arrays, and you've got the constructs you need to make this happen. So each name is followed by a colon, and the name value pairs are separated by a comma. So the basic structure is here. So you've got a bracket or a brace, whatever those things are, the squigglies, and then you've got either some white space, a string, then potentially the string being the name of the value that you're interested in, the name portion of the name value, and then the value after the colon. You can have multiple of those with commas. It's the basic way to read that diagram. Working our way through the various elements, you can also have an array, and arrays begin with brackets and end with a left bracket, and closes with a right bracket, and with commas in between them. You can also then have double quotes around things, so you can have strings, numbers, true, false, and so on. And you can also nest things together so that you can conclude multiple things together. And it's a very simple but yet very powerful sort of thing, right? And then you can have strings with essentially quotation marks, escape characters, hexadecimal, and so on. And then numbers, pretty much what you would expect, any kind of number, with the exception that there's no hexadecimal, right? There's no octal or hexadecimal format, but it's pretty much like every other number you've seen. White space, pretty much any kind of carriage return, and so on. And what that means is that a white space, there's no real concept of a line per se inside of JSON, unless it's inside of a string. So it basically, you can flatten them out, make them very small. So here's what it looks like, right? So we start off with our opening bracket, our brace, and then we've got a name. I should have clicked on that. So you got a name that is essentially got a colon, and then you've got essentially a structure that's associated with that. So glossary has a title, and then underneath of that you can have hierarchy of attributes. This corresponds to this sort of XML, but you'll notice there's a whole lot more characters inside of here, because you have to have opening and closing and all that good stuff, right? And some of that looks glossy also. I think we're missing a trailing slash there. So you can see, though, it's still much more verbose. So it is standardized, which it's something that is standard and universal in nature, so you don't have to worry about compatibility and various vendors taking it their own way and doing their own stuff. And you do have some other things where you can do, such as marshalling and pickling Pickling is a way of doing essentially compression, serializing it out to something that's relatively small. Marshalling is about crossing some sort of barrier or boundary. Sometimes you'll marshal between processes, definitely do marshalling across machines. So it's a means of serializing and deserializing. So you can access natively inside of the JSON libraries that are kind of pretty much there. This is built in for all intents and purposes. And you can have a dump string that basically I'm constructing here an array that has the attribute foo, and then it has a value of this whole structure, bar and then colon. So bar has these guys associated with it, right? So you basically are nesting things together, and then you can essentially dump them out using this dump s, right? Dump string. And so various other sort of variations on that theme of being able to dump out the various characters and print them out. That's not as exciting as though you can tie it in with some other stuff, such as this concept of a streaming I/O. This string I/O is a way of doing an in-memory buffer, and it's associated with text streams. You've dealt with file streams to some extent whenever you're doing a with file and using a handle on it to do your processing. It's a similar sort of concept, except here you're doing it with a string. There's reasons you do this. This is just kind of an example of showing that you can dump, this isn't dump s, but dump from what's essentially a file, but that file is really a string I/O port, so or a buffer, so it's a series of buffers. And you can see the results of that is that it's just kind of writing out what it was received, but as slightly different sort of braces or quotation marks and so on. You can do several ways of doing it. Here's the compact sort of encoding. That's what you're going to want to do if you're sending it across the wire, but you may want to see it in a prettier fashion if you're doing some sort of diagnostic and debugging. So this lets you be able to read it a bit easier, because you're basically sorting the keys and then you're organizing with an indentation of the various levels. And we could actually do that on some of these more complicated structures up here to make it a bit prettier. So to show that, and this is again going off script, but we'll see how it goes. Here, pretty much to there. Already have the sort key. So that. Get rid of this. It should work. And you can see that we're actually seeing it in a little cleaner way. Same thing. It's just that this is more readable, but at the expense of adding additional characters, which you probably don't want to do if you're sending it across some sort of a connection. You can decode using the load s. This is actually constructing, we're not saving it, but it's constructing a JSON object from this string that's being supplied. So we're doing load s. It's taking this string and essentially parsing it and converting it into a JSON object. You can also do it across various other types of strings. Again, load s is load string, so it's loading it in. Similar concept here with just load using the streaming I/O, string I/O functionality, so doing some stream processing there. And then you can add your own encoder to where you can do more interesting encoding and decoding depending upon what you're needing. So we've been talking a bit about file processing, an important topic, something that is relevant across lots of endeavors. So the idea here also is to show processing of a JSON file, right? So the idea here is similar in nature. I went out and I found a file that was interesting. So I went out and actually, I'm trying to track it down. Here we are. So I went out to data.gov, did some searching, and found a grant awards for, I believe it's the city of New York, since 2016. So basically that's what this is. So this is a JSON document. I just went out, found something that was JSON, and first of all started off by downloading it and saving it to a file so we can do file processing, right? it does, to walk through this file, it starts off, and you can see it's somewhat pretty here. It starts off with a metadata section. So there's two nodes essentially on this file, and we can see that when we go to actually do the processing, two high-level nodes. So you go ahead and I'll stick with the script for a moment, and then we'll go off script. So here I'm basically opening up the file. So I'm just doing a with open as file. Same thing you've done with lots of other files. This is a file handle, and I'm just basically saying JSON.load and give it the file handle and load it, and then I'm printing it out in a somewhat pretty sort of way. And we can see it starts off with there's data and there's metadata in through here somewhere, or meta. So meta and data, those are the two things, and it starts off with data as the first thing. What they're attempting to do here is make it fairly tight. This is just an array of arrays, basically, is how to read this. So going up to the very top, not that far up, the top of that file, and it may make sense to go back over into the browser. At the very top, it's sorted the keys. That's why data is first. Meta is actually first in the file, but because we have sort keys is true, meta comes later. I'll go ahead and remove that. So we see meta first. And so sort keys is all it does is at the top level sorts it based upon the key name, all right? And probably may even do it down further. So we start off with meta. Inside of meta, there's a view. Scroll down a little bit. We'll see there's a columns. And the columns, it gives us, for each one, a name. So you have some sort of a identifier, SID. You've got another name, which is ID, and then position, created at, created meta, updated at. So these are usually your created, updated record sort of tracking things. Meta, again, not terribly useful. And then we have 2016 organization. So I'm guessing that's the name of the organization at 2016. And it's actually listing, this is kind of interesting underneath of the meta, it's actually showing you some cache contents and the top sorted by count. So PS 334 was the most frequently occurring with 20, then 375, 6, and so on. Scrolling on down, we're into the next name, which is project address. And again, they seem to be listing out some of the top, both the longest, I'm assuming the largest is the longest string, but also ordering descending by count of the addresses as well. So that's a lot of data about the data. That's what metadata is data about the data. This is something that you end up doing is taking a file and having to pick it apart and figure out how it works. The reason we're going through here is that what I kind of care about for what I'm doing with my example is this name of the column, essentially. So council district, and again, it's got various metadata that you might care about, but I didn't. The community board, the name of that column, how much they were rewarded in 2016, and this is again descending. Somebody got 20 of them got a $250,000, the rest 200,000, 35,000. Interesting that's not in, 17 of them got 500,000. So we're ordered by count, not by dollar amount. So basically who got the most, the various distribution. And as you would expect, there's fewer of the big ones. So somebody got 330,000, somebody got 350,000. One got 175,000. So we have the smallest, and there's also up here probably a largest. So somebody got 600,000, and I didn't quite see that one, but I probably rolled right over it. Or it may not have been included in those counts for some reason. There's some other stuff here I'm not using. I'm not using like the format. That would be how you wanted to display it. It looks like they, for some reason, selected Canadian dollars. I'm not sure why that would be. But anyway, Moving on to the next one, we've got a postcode. Again, distribution by the various values. Then the borough that it's in inside of New York. And again, the longest name and the shortest name, so everything seems to be in Manhattan's borough. And then the latitude and some different values here. And there's probably going to be a longitude coming up as well. Yep, there's longitude. And again, some different values. So with that, you could actually pinpoint where these businesses were or organizations. Census tract. So something used whenever you're calculating the census values, a binary number of some sort, a bin, which is, I'm not too sure exactly what that is, because this particular, it doesn't tell you a lot of what it is, and you can't really infer it from that, but it's some sort of identifier. BBL doesn't really give you what that means. So this isn't exactly a data dictionary, but it has a fair amount of metadata, NTA. Yeah, I'm not sure exactly what those are. Maybe regions? Yeah, it seems like it's probably a subsection inside of a borough. Then moving on to a few other things that aren't really terribly interested for what we're looking at. Some table author, where it came from, and so on. But here we get down to the actual data. And so here you can see the values, and it's just, this is data is an array of arrays. And each one of these corresponds to that metadata we just went through up above, right? So that you could associate the name of that particular item to its position, ordinal position in this array. And there's multiple of these over and over again. So that's the kind of the nature of this file. And you can see that also in the browser. So taking a look back at it, we've got, this is what you get directly from the download. You got meta, you got view, which is a selection of those various columns. Then you can go into columns. And I was seeing if there's anything here that told us anything terribly useful. It's just telling you what capital projects are through Manhattan. Available to city agencies, nonprofit organizations, cultural institutions, and public schools. So interesting data, but a very narrow sort of data for one particular year is what this is, and it's available somewhat through the whole open government sort of stuff. Here's the columns that we've went through, and then we can go into the project title. The name and so on. So we can go through all these things, which we already went through, and it's down to the data, which should be in here. So here's the data. And again, this is what it looks like without having been made pretty. So it's a little harder to read, but you can kind of get across what it is. So back to our example, what I've done here is I've opened up a file, read it, and then dumped it out to the screen. We can do something similar without having to go to that part of doing the file. So the whole web concepts is around requests and responses. So whenever you hit your favorite web page and go to a website, you issue essentially a GET request most of the time. And that's exactly how this works, is we've got requests and we're saying GET. And I give it that same URL from which I downloaded the file. And then you get back a response. Here, there's several things on that response object, but the thing we care about is the text, because I'm just assuming it's going to work out, right? So if we import that in import request and then run it and get back the response, we can get back the response text. And that response text contains the actual JSON that we're interested in. In this case, it didn't work, which is always great. Let's try it again. See if it'll do it the second time through. There we go. That time it worked. So that's the nature of the web as well, that sometimes things don't work. Same data we got before, right? Just pulling it directly rather than downloading it to a file first. So, but by doing that, I can load it using this load s, so load string, and I actually created a grants object, and that's what we're looking at here. So the next thing is to do something interesting with it. So let's iterate through the top level nodes, and you can see there that it's got meta and data. You could actually do something crazy here. And go through, wasn't exactly what I meant to do. So this should be this. Maybe this. That it? Yeah, there we go. So before we were just listing through the characters that came back. So here what I'm saying is, okay, this is a dictionary. This top level thing is a dictionary. What are the keys? All right, so the keys are meta and data. Underneath of meta, you've got view. Underneath of data, you've got a whole bunch of things. And you could actually do it one more level if you wanted to go crazy. So subnode and subnode out of subnode. And this will basically let us take a look at the keys, you know, 2 levels down. If I get my indentation right. And I probably need to do this. That. Oh. Anyway, going off script enough anyway. So moving on. So we've got our meta and our view. Underneath meta, we've got view. Then we've got columns. That's we can see that if we go take a look at that file early on. So columns is underneath of meta. So meta, view, and then columns, and these are the columns we care about. And so what I want actually is for each one of those columns, I want to know their name. So I can run that and I can see these are the names. And I might want to know, so what I'm doing is I'm taking those names and I'm essentially shoving them into a list, right? So I'm taking the name and putting it into this list at the end. And so you probably want to know how many are there, right? That's a reasonable thing to know. And there's 22. So there's 22 different fields and so on. So we can then go through and take a look at the data. So here I'm just getting the dictionary of data that is inside of that JSON node. And I create an empty list that's going to be made up of dictionaries. So the reason I'm doing this is I want to create a pandas data frame from this JSON document, but I only want some of the fields. I don't need everything. I just want to know the names and of the columns, and I don't want all the summary stuff. I just want to be able to essentially convert that into something that I can make sense of for my purposes, right? So I want to know this information. So what is the whenever I look at these items, what are they? What do they mean, right? So that's basically the idea. So drilling down into the actual data itself, I want to turn this into something that has names associated with it. So it's essentially columns in a data frame. So to do that, I've got my list of columns and I've got my data. So the process to go through here is to basically create an empty list. Then for each item in the data, create a dictionary. So it's an associative array. And then for each one of those items in that data frame, which we know to be ordinally based from 0 to the length of the data items, so they correspond also to the names of the view list, so the names of the columns. I want to basically create a dictionary, populating it, setting the name so that I can then put it into a data frame. So if I run this, it's going to take a little while, not a whole lot of time. But what it does by doing that, and it's did it fairly quickly, but it's basically letting me go through and construct this. So I've now got a data frame that is the corresponds to what we just saw. So if I I dock that on one side, go and, that's not it, bring over this so I can do it side by side if it'll cooperate. Oh, not doing side by side, we're doing, there we go. So we can now take a look at that data frame and compare it to the actual data we got earlier. And it's cutting it off because of a mixture of the zoom. Maybe go a little smaller so it'll show me more. So to find it, I'm going to be lazy and just do a search. So the first record underneath data does indeed match up to this. The SID is the same, and we know that SID is the first thing because it was listed in that metadata that it was. The next thing that we get is an ID. That looks an awful lot like a UUID. So that's a uniform, unique, or universally unique identifier is what it's supposed to be. So we have position, we have a created at. That's probably a Linux time. We would want to convert that over because that's probably the number of seconds in some magic date. The next thing is null. So if we scroll over, the next column is none for created metadata. Then there should be an updated at, which happens to be the same as the created. Then some metadata that's empty with a empty brace. And then we've got the 2016 organization. So we know that that is 107 Street Pier. And then there's an address for it as well as 107 East, or 107th Street East, Plazaneda or something. And then pier renovation. So it looks like here that they were working on the pier, spent $250,000 making it better. And if that's the case, then up here we should see $250,000 for the award. There's no postal code apparently where the pier is. It is in Manhattan, and we don't have ladder longs for it as well. So by doing that, we've now got it into this construct that we can then do something like save it, right? So we can then turn around and say to CSV, whatever this was it Capital Grants Awards? So we'll just say and by doing that, we've now written it out as a CSV file so that we can then do with it whatever we wanted to, right? So that's an important concept, is it being able to basically massage this data, get it into a usable situation. And I'm opening up over here in a separate window a browser so we can actually see that it's here as a CSV. And we did have our index here at the first. Should have figured out a better index. It could be that this SID is a pretty good one. But then you can pull that into here and actually do data with it that's a whole lot easier to deal with than it might be in its native format. So this is actually something you do quite a bit of. It's not a contrived sort of thing. Being able to take data from some place, convert it from maybe not such a fantastic sort of structure into something that you can actually use is a very common workload that you do. What you would normally do also with this is go through and figure out if you can figure out these things that are missing, right? So because we have a fair amount of data missing on some of these, such as the latitudes, longitudes, census tract, and some of this other stuff that just don't seem to be present. Postal codes not there, and so on. Also, you would probably want to do things like convert these dates, although given they all seem to be the same one, you would probably do some analysis of variance and figure out that there's really not much point in that data because it's not terribly useful. Where this also would come in handy is if you're doing analysis over multiple years, right? So you would want to take a look at see how much is being awarded per each one of these entities each year. And then also typically you would combine this into a larger data set. So you would grab multiple data sets, go through a process of standardization, converting them all to the same data set, probably not CSV. You would probably do something else. You wouldn't do JSON, but you might do something like Parquet, and save it off as a different file format. So just for fun, we'll go and say do a to Parquet. So then we can show you one more thing before we wrap this up. So you might do this, right? And I probably need to install something. PyArrow. Let's try with that first. Parquet is a columnar data store. It probably one of these probably installs the other. That's the reason I'm not sure which is which. But Parquet is a columnar store, and what that means is that it stores things kind of in a column sort of oriented approach rather than row-wise. It's a very fast and it also has compression associated with it as well, so you can compress the files as well as saving them in something that's essentially a binary format. And then we can see if this will work this time. Yep. And back to our file. And you can see it is smaller than the CSV. I don't think I have a Parquet viewer installed. Might be able to find one quickly. Yeah. I've used this in the past. But this is it's not going to be terribly unique because it's basically just a tabular representation of the data. So that is showing a kind of common workload you'll do. As part of it is, it's not exactly data science, but as data scientists we often do data wrangling and data cleansing and manipulation. So in that regard, it is something that you do quite a bit. Let's see if that happened to associate with it. Yeah, there we go. So this is the Parquet viewer, and you can see it's basically just letting you see the same stuff that you could see in Excel, but you're doing it without having to load it into a different sort of program. So pretty useful. So at that point, you've now seen a Parquet file. You've now seen a JSON file. You saw the process of converting between Parquet, or between JSON to CSV and also to Parquet. That process that we did here, logic-wise, is not so different than what you do whenever you're dealing with XML to data frames. You're dealing with a hierarchical structure. It's just that it's a tighter hierarchical structure so that it doesn't have as much noise in it with the opening and closing brackets and all that stuff. So with that, I'll go ahead and wrap this up. This request, this lecture is in response to a request for a discussion of JSON. So if there's anything else that is of interest to you, let me know. I'll be glad to talk about it. And it's always fun to branch out into different stuff. So if you have any questions about your assignments, let me know. Keep up the good work. Do keep in mind the clock continues to tick. So the number of days between the submissions gets narrower the longer you wait. So pretty soon you'll reach the place where it may not be attainable. So keep up the good work. Keep submitting those submissions, and I'll turn them around as fast as I can. If you have any questions, let me know. I'll talk with you again soon.